Hello, my name is David Frank, and my project topic for my thesis, cybersecurity, is enhanced malware detection with browser extensions. And the goal was leveraging supervised algorithms for identifying malicious links. And the objective of this project was to develop a user-friendly browser extension and for everyday use that can detect between malicious and safe links. And the method that we used was actually the supervised algorithm, and we carefully chose these algorithms that would help to boost the success of this project. And the outcome was actually getting an efficiently working Chrome extension that does this distinguish between safe and malicious. And because of the increased sophistication of cyber attacks and the frequency, traditional measures really struggle to keep pace. And traditional antiviruses that we have been using within the years have actually been using signature based to for detection, and this signature base has become overwhelmed because of how cybersecurity, the cyber criminals have been so innovative in how to brute force systems and all that. So this traditional methods are not really efficient in keeping pace with the rate of cyber attacks. And the significance of this research was to develop a user-friendly and something that it will be very easy for anybody to install and to save users from the evolving malicious threat landscape. So to we move to the research question, which is how can browser extension effectively identify and mitigate risks associated with malicious links? So this was the question that was in my mind while working on this project. How can we integrate supervised algorithms to enhance detection of and the detection of malware, and how can we scale it? So the next was the methodology and the overview. And the first thing that we had in mind was data, because we know I know that data, when training data sets, it is very important to know the have a good quality data to avoid the system being biased and to avoid a lot of issues along the way. And that's why we I was really particular about the data preparation, the cleaning process, the standardizing of the data sets, understanding that the quality of data was very important, and choosing feature selections like the length of the malicious links, the error codes that it sends back, and so many others. Also, when the domains were registered and all that, and the model training too. We I decided to go with the libraries like TensorFlow and Sktlern, because these are the efficient technologies for malware detection. So we move on. Machine learning models that we use was DNN supports vector, random forest, decision trees, and XBots. And the performance that was recalled here was actually incredible, and because it really showed a lot of promise for integrating machine learning and browsers to work hand in hand to fight this ever evolving landscape. And we move to the next. So this was the summary of the metrics that was gotten in this project, and DNN um, demonstrated the highest, indicating very strong and correctly identified safe URLs. So we'll move to the development of this browser extension, and we use I we used um, technologies like Python, which was a very good alternative to use because of how simple Python is and how fast and very powerful APIs that it has, frameworks and all that. And JavaScript was also definitely because of the user interaction, HTML, CSS, and all that. And Flask, most especially, was a very, very vital decision that we needed to take because of how the Flask API actually works hand in hand with error handling and HTTP response and request and response. And sketch learning and pandas and numpy was another wonderful one. And Google Chrome developer tools has was the best alternatives for a browser because of how universally accepted it is. And we'll move on. So the browser extension functionality is such that the Flask API actually listens to the URL ports and tries to pick the URL that the user is actually trying to go to, and then it sends that post request to the it sends the post request to our prediction code, and which actually analyzes it and then sends back a pop request. So it basically communicates together to actually determine if a platform is safe or not. So we'll move to the next. The result of this finding was that we actually found it was actually rewarding because it worked on so many platforms. Although we had issues with finding malicious links, and we actually went for synthetic ones before we later found um, actual malicious links, which actually worked very well. Although the little challenges we had was false positive and all that, and this doesn't really change anything because it helps us to reinforce our tactics on training data and also keep on moving, basically pushing the grounds of this research, not just stopping at where we are at, and but also scaling it after this. And the goal is to move forward with this and see where it goes in terms of scale. So the key findings in for our literature review was that Abewale actually went did this. I think this was 2019. Before, he still repeated this about 2022. He actually used his model was actually getting the features, was getting the images and the text from the platform to analyze it to see if it was really the platform or if it or it was just a fake platform. And also other people, other forerunners of this project actually went forward in their research, and most of them achieved a high level of precision and accuracy in detecting malwares, leveraging on supervised supervised algorithm. So, because the integration of supervised algorithms into these platforms has actually been very promising, and recent research from people like Jin Lee, from people like Abewale, from Chrisman, and all that have come together to give a concrete potential that moving forward with browser extension, integrating supervised um, algorithms with browser extensions would really help to mitigate the risk of malicious content and getting infected with these things. And one of our goals was not just random. We actually had three class of viruses that we had in mind when working on this, which was malwares, adwares, ransomware, adwares, and also malwares. And this was the this because this is the very rampant source malware distribution that the threat actors have actually been leveraging on to exploit um, users of their privacy and their data. So moving on, the comparative analysis of this was a really high report on the accuracy of how these algorithms performed. And the methodology and approaches that these forerunners actually put in place really went a long way to give us that push and that belief that this would be a game changer in the threat landscape. And the feature integration was also a wonderful one, because this extraction of different features showed a lot of promise in this field. And the literature review conclusion was personally for me that these people actually this although Abewale was mostly about phishing, his work was based on phishing, and the results coming out from this project showed a lot of promise and high accuracy to show innovation in this approach and all that. So we move to the next. And the future work is on this. It's not just ending here, but adaptive learning, continuous retraining, because we know that data sets most of the time gets biased, but continuous training and adding more features, um, extraction to this would really improve this. And also another key point in our future work is also user interface. So because we need to use something appealing to the users, and this would really help to push this product to the wall. And also collaboration with collaboration opportunities with cybersecurity firms that would in turn scale this into other products, and not just browser extensions, but other products that would actually help to safeguard the digital assets that we all have. And basically, the conclusion of this for me is that this project demonstrates a potential of using supervised machine learning and in browser extensions, because uh, uh, um, um, it has really shown a lot of promise, not just in our project, but forerunners of this project. It has really shown that moving forward with this would really help and really put us at that forefront of the threat, to mitigate threat actors and handle and use threat models to to go ahead of these threat actors. So these are the references, and we'll be awaiting questions if they are concerning this. But personally, it was a joy working on this project, because it was not just a project it was not just about me, but it also showed promise on what this project entails, and the projection and scalability of this project. Thank you.